All right, the last four are kind of an exercise in logarithms. And inverses. So let's knock those out very, very quickly. I'm going to start with number 27, which says the given function is 1 to 1. So in order for you to be able to find the inverse, which is f to the negative 1, you've got to have a 1 to 1 function. And there are 4 steps to solving this type of a problem. So let me take a snap of it and pull it down here to the bottom, make it a little bigger. I'm old and I can't see. All right, so f of x equals x over 7 minus 2x. So I'm going to rewrite this as y equals x over 7 minus 2x. That's my first step, rewrite the function. My next step is to, you guessed it, switch x and y. So now I'm going to have x is equal to y over 7 minus 2y. Because when you invert something, you simply switch the x and the y and it just inverts its place. So why not do it with a function? Now let's multiply both sides by 7 minus 2y in order to get rid of this fraction. Because you know we don't like fractions. We need to clear those things. Some of us might love them, but you still have to multiply both sides by 7 minus 2y. Can't get away from it. So you get 7x minus 2xy is equal to y. Now, me being me, I want to get my y's together because at this point I want to solve for y. That's why I multiply both sides by 7 minus 2y. So I'm going to move that negative 2xy over here with the y to get my y's together. So 7x is equal to y plus 2xy. And all I have to do is factor out this common y, and I'm left with 1 plus 2y. Equals 7x. Divide by this quantity in the parenthesis, 1 plus 2y on both sides. I'm sorry, that should not be 2y, it should be 2x. Y'all know a teacher makes at least 2 mistakes a day. You can count them. 1 plus 2x, I need to say. So divide by 1 plus 2x on both sides, as I have done. Cancel that out, and you're left with y equals 7x over 1 plus 2x. And in proper form, our inverse would be f to the negative 1 of x is equal to this answer, 7x over 1 plus 2x. And that's all there is to find the inverse. 4 steps. Rewrite the function, interchange x and y, solve for y, and then rewrite it with f to the negative 1 of x. Not too terrible, I hope. On to 28. How do we solve a type 1 exponential equation? Now, I call this a type 1 equation because you don't have to do a whole lot with this guy. All you have to do is write them in terms of the same base. So you could do this problem without a calculator. And that's what we're going to do. We're going to do it without a calculator. Now, this first side here is already written in terms of a very small base, 3 raised to the 8 minus 5x. But that 9, can I write it in terms of 3? I hope you know that it is 3 squared. That's what 9 is. But how do I get rid of that 1 on the top? I've got to use the negative exponent rule. I've got to remember that anytime I have a reciprocal function, 1 over a number, it can be rewritten as that number raised to the negative exponent. Now, if you don't know that, now you know. All right, so 8 minus 5x and negative 2 are equal quantities because we got the same base. And as I tell my students, you drop those bases like they're hot potatoes. And we've got 8 minus 5x is equal to negative 2. What do? You move this 8 over, make it a negative 8, and it becomes a negative 10. How convenient. Negative 5 is equal to negative 10, so divide by negative 5, and you guessed it. Bob's your uncle, the world's your oyster, and x is equal to 2. And you don't have to plug that in unless you just want to check it out to make sure. I'm a big fan of checking things out, so let's see what happens. If I put a 2 in here, I get a 10. 8 minus 10 is negative 2. And 3 to the negative 2 equals 1 over 3 squared, which equals 1 over 9. Who knew? You did not. All right, so the last two that we're working on, 29 and 30, are all about logs. One deals with the natural log or the exponential e, and the other just deals with the regular log. So let's get those up here and take our time. I'm sad that they were bunched up like that. I just thought I was going to have enough space to write underneath them, but I did not. All right, so 29 says let's solve the equation. All right, so first of all, let's get rid of these parentheses so that they can look kind of normal. E raised to the 3x minus 1. And e is the exponential e that represents the limit as, like, say $1,000 goes to infinity. Like, what value is it going to converge to? You'll notice it converges to the e value, but you'll see that in calculus. Somebody will work it out for you. But this is the exponential e. And then 4 times negative x is the negative 4x. Now you can drop these e's like they're hot potatoes, and you're left with 3x minus 1 is equal to negative 4. All right, let's get our like terms together. Move that 3x over. Negative 1 is equal to negative 7x, because you have to subtract the 3 when you bring it over, because it's positive, you know. Divide by the negative 7, and you've got it. 1/7 is equal to x. Positive 1/7. Now, how do we check this? Look at that x. Let's put it in the calculator. Let's see what the calculator will give us. When we plug this in, we have second ln. That gives us an e to the 3 parentheses 1 divided by 7 minus 1. Gives us this value. Now let's do that again, but this time put the 4 in there. Negative 4 times 1 divided by 7. Ta-da! Same value. So 1/7 it is. We win. Last question. Logarithms. One thing for you to remember about a logarithm is that a log is an exponent. That's all it is. So the inverse of this logarithmic function is an exponential one. So what we do is we write this exponentially. So a raised to the bc will always be log base a of c is equal to the exponent. So when we rewrite this, it becomes x raised to the 3rd power is equal to 64. So what do we have to do? Take the cube root of each side to find out the answer. Now the cube root of 64, I know that to be 4. So that means x is 4. But if you don't know that, you come over to this calculator, you press the math key, and you go down to the cube root button, which is number 4, and you put 64 in there and press enter, and it'll tell you that it's 4 until you can remember it. Well, that's that. I told you it was going to be quick. Good luck as you continue, and I think the next section I'll do all 9 or 10 of the problems so that we won't have to, wait for, what's coming next. You won't be in suspense. You'll have the last problems, and that will be the completion of the review that I'll provide for you. Good luck as you study.